Dear students, today I will be teaching you continuous time Fourier series. This is lecture number 14. Before starting Fourier series, let me put this block diagram. Fs is Fourier series operator. Input is x of t. Output is x of k. Output is x of k. X of t is continuous signal, periodic signal. X of k is discrete, non-periodic. What I mean to say is, a continuous time periodic signal x of t gets converted into a frequency domain signal x of k, which is discrete and non-periodic. First, let me define what is Fourier series. I am going to write now, let x of t be a continuous time, x of t be a continuous time periodic signal having a fundamental period equal to t. Then x of t may be represented by an exponential Fourier series, as given below. X of t is equal to summation k equals minus infinity to plus infinity x of k into e to the power jk omega naught into t, where omega naught is equal to 2 pi divided by t. This is equation 1, where x of k equals Fourier coefficient and is given by the formula 1 by t integration over one period. The symbol means integration is over one period. X of t into e to the power minus jk omega naught into t dt. See what this symbol t means. The limits of integration is left to the discretion of the person who is involving in the solution of x of k. For example, it could be 0 to t. It could be from integration could be from minus t by 2 to plus t by 2. Integration could be from minus t by 4 to plus 3t by 4. Upper limit minus lower limit should be t. That's what this means. The limits of integration is left solely to the discretion of the person who is finding x of k. Equation 2 is called analysis equation. Equation 1 is called synthesis equation. Equations 1 and 2 may be represented symbolically as x of t has a Fourier coefficient x of k. Inverse of x of k is x of t. Here I will write Fs means Fourier series semicolon omega naught. This is how equations 1 and 2 are symbolically represented. This is called as pair representation. I again repeat. We have got a continuous time signal which is periodic, has got a fundamental period equal to t. This signal x of t gets converted into x of k as per this block diagram. What is x of k? Fs operating on x of t. X of k is discrete, non-periodic. Now, x of t is represented as an infinite summation on x of k with x of k multiplied by corresponding exponentials. Equation 1 is called exponential Fourier series. X of k in equation 1 is called Fourier coefficient and is computed in the formula 1 by t integration x of t into e to the power minus jk omega naught t dt. This symbol means Limits of integration is left to the sole discretion of the person who is solving the problem. I can give examples of how the integrals will have the limits 0 to t, or it could be minus t by 2 to plus t by 2, or it could be minus t by 4 to 3t by 4. Now certain important things I am going to tell you about this Fourier series. See, any complex number, for example, 1 plus j1 can be written as root 2 into e to the power j tan inverse of 1 by 1. How did you get this root 2? Root 2 is nothing but square root of real part square plus imaginary part square. So this becomes root 2 into e to the power j pi by 4. This is called as rectangular form of representation. This is called exponential form of representation of a complex number. What I mean is, any complex number will have magnitude and angle. X of k, note, x of k is complex. By that analogy, x of k is complex and hence may be represented in the exponential form, as x of k is equal to magnitude of x of k into e to the power j times theta of k. The plot of magnitude of x of k versus k is called amplitude or magnitude spectrum. This spectrum exhibits even symmetry. This spectrum exhibits even symmetry about k equal to 0, when x of t is a real signal. Very important. The plot of theta of k versus k is called phase spectrum, or angle spectrum. This spectrum exhibits odd symmetry about k equal to 0 when x of t is a real signal. Now, based on this concept, we will do a problem. The problem is, find the Fourier coefficient. Find the Fourier coefficient x of k. Also plot amplitude and phase spectra. Spectra is the plural of spectrum. The waveform is as shown here. T, x-axis is t, y-axis is x of t. the waveform given. It is called sawtooth waveform. This line is at right angles to x-axis, which is at t. What is the equation of this straight line? What is the equation of a straight line? The equation of a straight line is y is equal to mx, because the straight line is passing through origin. See, the equation of a straight line, is y is equal to mx plus c. C is the intercept. In this case, c is 0. What is y? Y is x of t. What is x? T. What is slope of this line? So if you call this as theta, slope m is tan theta. C is 0 because the intercept is 0. What is y? Y is x of t. What is m? Tan theta. Opposite side by adjacent side. That is m is 1. Tan theta is 1. So 1 into t plus 0. That means x of t is equal to t. Equation of the straight line is t. You can check it. When t is equal to 0, it is 0. When t equal to 1, its value is 1. Equation of the straight line is a must for doing the further analysis. So I will put this as a note. The mathematical description of first cycle of x of t is equal to t for t varying from 0 to 1. Recall x of k by definition is 1 by t integration with respect to t over 1 period x of t into e to the power minus jk omega naught into t dt, where omega naught is 2 pi by t. This implies x of k is equal to, what is t here? This is t. T is 1 second. So it is 1 over 1 integration from 0 to 1. X of t is t. E to the power minus jk. What is omega naught? 2 pi by t. What is t? 1 second. Therefore omega naught is 2 pi into t dt. Please note that omega naught is 2 pi by 1. Now this integration has to be performed. For that we'll make use of a standard integral. Integration of t into e to the power at dt is equal to e to the power at divided by a square into at minus 1. Recall, this is a very standard integral whose result you have to remember. To derive this result, we would have used integration by parts. Now, this integral has to be solved using this formula. If you call this as equation 1, call this as equation 2. Comparing equations 1 and 2, we get what is a? What is a? A is nothing but minus j times 2 pi k. Correct? Hence x of k is equal to integration from 0 to 1 t e to the power minus j 2 pi kt dt is equal to e to the power minus j 2 pi kt divided by a square minus j times 2 pi k whole square into minus j times 2 pi kt minus 1. Limits from 0 to 1. Limits from 0 to 1. Now first put the upper limit. This implies x of k is equal to, put the upper limit. Before that, this is, what is j square? J square is minus 1. So you get, put the, so I will write one more step. E to the power minus j 2 pi kt divided by, before putting the limits, let me do some minor simplification. J square is minus 1. So it is minus 4 pi square k square into minus j 2 pi kt minus 1, limits from 0 to 1. Put the upper limit, minus 1 over 4 pi square k square, keep out, put the upper limit. If you put t equal to 1, you get e to the power minus j 2 pi k into minus j 2 pi k minus 1 minus lower limit. If you put t equal to 0, e to the power 0 into 0 minus 1. E to the power minus j 2 pi k is 1. So this becomes minus 1 over 4 pi square k square into minus j 2 pi k minus 1 plus 1. This 1 gets cancelled. So you get minus into minus plus. So you get j divided by 2 pi k. Condition k not equal to 0, because when k is 0, x of 0 becomes infinity. You please remember, e to the power minus j 2 pi k, e to the power minus j 2 pi k means cos 2 pi k minus j sin 2 pi k. Is a note. Cos 2 pi k is 1, sin 2 pi k is 0. Therefore, e to the power minus j 2 pi k is 1. This aspect I have used here. So why I put the condition k not equal to 0? When k equal to 0, x of k becomes infinity. This I will call equation 3. So how to find the value of x of k when k is 0 is the next task. So what I will do is, to find x of 0, put k equal to 0 in equation 3. Then x of 0 equals integral 0 to 1 t dt. Because e to the power 0 is 1. T if you integrate, you get t square by 2, between 0 and 1. So you get half. So let me now summarize. Summarizing, we get x of k is equal to j divided by 2 pi k when k not equal to 0, equal to half when k equal to 0. Next objective is to draw the amplitude spectrum and the phase spectrum. I want to assure you people that people may tell you that Fourier series is difficult. Strictly speaking, if you know to do integration properly, this question can be solved very easily in the examination. See, please note, any complex number a plus jb has a magnitude root of a square plus b square and an angle tan inverse of imaginary part by real part. This is one. Second one, j has got magnitude 1, angle pi by 2. 3. Minus j has got magnitude 1, angle minus pi by 2. Hence, please watch. Hence, what is magnitude of x of k? Magnitude of j is what? 1. So you get what? 1 over 2 pi k modulus. When k not equal to 0. What is modulus of half? Half only. This formula is required for plotting the amplitude spectrum. What is theta of k? Theta of k. When k is positive, for example, take k is equal to 1. What you get? J by 2 pi. K, right? So what is the angle of J? What is the angle of J? Angle of J is what? Angle of J is pi by 2. So I'll write pi by 2 when K not equal, when K is greater than 0. K greater than 0 means take any positive value of K, you will have J. The constant number, what I am saying is, let us take K is equal to 2. Then what you get? J divided by 4 pi. What is the angle of J? Pi by 2. What is the angle of 4 pi? 0. The constant will have an angle equal to 0. Angle is provided by J only. When what is the angle of half? Angle of half is 0. When K equal to 0. When K is negative, for example, when K is minus 2, what you get? Minus J by 4 pi. What is the angle of 4 pi? 0. What is the angle of minus J? Minus pi by 2. So minus pi by 2 when K is less than 0. Please note that amplitude spectrum is drawn using this equation. Amplitude spectrum must exhibit even symmetry. Phase spectrum is drawn using this equation. Phase spectrum must exhibit odd symmetry. What is important is when K is positive, you will have J. So angle pi by 2. When K is negative, you will have minus J. Therefore angle is minus pi by 2. Still I can make, what is the angle? I can make this further clear. J by 4 pi means angle of J minus angle of 4 pi. Angle of J is what? Angle of J is what? Pi by 2. Angle of 4 pi is 0. Here, what is the angle of this? What is the angle of this? What is the angle of this? Angle of minus J minus angle of 4 pi. Angle of minus J is minus pi by 2. 4 pi is a constant, therefore its angle is 0. So the hardest part is to write the amplitude spectrum and phase spectrum. But majority of the times standard problems are asked, so you need not worry. I am going to draw now amplitude spectrum. X-axis is K, Y-axis is magnitude of x of K. K equal to 0, 1, 2, minus 1, minus 2. Few representative values I will show. When K is 0, what is the amplitude? Amplitude is half. When K is 1, what you get? 1 by 2 pi. 1 by 2 pi. When K is minus 1 also, you get 1 by 2 pi. When K is 2, what you get? 1 by 4 pi. When K is minus 2, you get minus, when K is minus 2, because of modulus, you get again 1 by 4 pi. This continues till, as you go towards minus infinity, the amplitude keeps decreasing. As you go towards plus infinity, the amplitude keeps decreasing. If you see this spectrum, sorry for the phone call, what value you get at K equal to 1, same value you get at minus 1. What value you get at K equal to 2, will get at minus 2. What I mean by that is, this spectrum exhibits even symmetry. Very, very important. This I have told in the beginning of this session. Next I am going to draw phase spectrum. This must exhibit odd symmetry. X-axis is K, Y-axis is theta of K. When K is 0, what is the angle? 0. This is K 1, 2, 3, minus 1, minus 2, minus 3. When K is 1, what is the angle? Angle is pi by 2. When K is minus 1, what is the angle? Minus pi by 2. When K is 2, what is the angle? Pi by 2 according to this. When K is minus 2, what is the angle? Minus pi by 2. When K is 3, according to this, angle is pi by 2. And when K is minus 3, the angle is minus pi by 2. This keeps going till minus infinity, this keeps going till plus infinity. Here the samples have got constant amplitude. This spectrum exhibits odd symmetry. This spectrum exhibits odd symmetry. And this even symmetry and odd symmetry concept will hold good only when x of t is a real signal. Please keep this in mind. So in the examination, you will be asked to find what is x of k. From x of k you have to get what is the magnitude and angle. Using magnitude, we'll plot magnitude spectrum. Using phase, we'll plot phase spectrum. So this is magnitude spectrum, this is phase spectrum. We'll proceed to the next problem. Evaluate x of k. Plot amplitude and phase spectra. Amplitude and phase spectra. The signal is shown in this figure. X-axis is t, y-axis is x of t. Equation of this is e power minus t, 0, 1, 2, 3. This is minus 1. Okay. So this is a periodic waveform. The mathematical description of x of t over the first period is x of t equals e power minus t for t varying from 0 to 1. In this equation is already given, so you need not find the equation as we did in the previous problem. Recall x of k by definition is 1 by t, integration with respect to t over one period, limit is left to you. X of t into e to the power minus jk omega naught into t dt. Omega naught is what? 2 pi by t. What is t here? This is t. This is t. T is what? 1 second. Hence, x of k is equal to 1 over 1 integration from 0 to 1. X of t is e power minus t into e to the power minus j, omega naught is 2 pi k into t dt. I'll add the powers of these two exponentials, integral 0 to 1 e to the power minus 1 plus j times 2 pi k into t dt. Integrate this. If you integrate this, you get e to the power minus 1 plus j times 2 pi k into t divided by minus 1 plus j times 2 pi k, limits with respect to for t from 0 to 1. From 0 to 1. So I'll write this. This implies x of k is equal to minus 1 over 1 plus j 2 pi k into, put the upper limit t equal to 1, you get e to the power minus 1 plus j times 2 pi k. Put the lower limit, e to the power 0 is 1. So now this is nothing but minus 1 over 1 plus j times 2 pi k into e to the power minus 1, e to the power minus j 2 k minus 1. E to the power minus j 2 pi k is 1. So e to the power minus 1 will be minus 0.632. This will simplify to minus 0.632. Use calculator. E to the power minus 1 is minus 0.632. Minus of minus, it is plus. So you get 0.632 divided by 1 plus j times 2 pi k. This is the expression for x of k. This implies what is magnitude of x of k? It is a complex number. So 0.632 divided by square root of real part square plus imaginary part square, 2 pi k whole square. What is the angle? What is the angle? It's a complex number. Angle of 0.632 is 0. Only this complex number will provide the angle. Minus of, why minus? Because the complex number is in the denominator. Minus tan inverse of 2 pi k imaginary part divided by real part. So we have to find the angle of 0.632 which is 0. We have to find the angle of this complex number and add both the angles. 0.632 being a constant will give an angle equal to 0. This complex number being in the denominator, a minus sign has to be taken for the angle. Tan inverse of imaginary part the real part. Using this we plot the amplitude spectrum. Using this we plot phase spectrum. Amplitude spectrum must exhibit even symmetry. Phase spectrum must exhibit odd symmetry. I'll create a table now. This is k. This is magnitude of x of k. This is theta of k. Theta of k is in radians. -2, -1, 0, 1, 2. Few values I have taken. You can take even -3, any number of values you can take. 5 representative values are sufficient. In this expression, put k is equal to -2. If you put k equal to -2 in this expression, the value that you are going to get is 0.05. If you put k equal to 2 in this expression, you will get 0.05. This is because of even symmetry. If you put k equal to -1 over here, you will get 0.01. If you put k equal to 1 here, you get 0.05. When you put k equal to 0 here, when you put k equal to 0 here, you get 0.632. Now come to the angle part. 0.01, sorry, 0.01, yes. Now you come to this expression. When k is 0, 0, an odd signal must be always 0 at the origin. If you put k equal to -2 in this expression, you will get 1.491 radians. Please calculate. So calculator must be in the radian mode when you do this analysis. It should not be in the degree mode. It is 1.491 radians. When you put k equal to 2 here, you will get negative of this angle because it must exhibit odd symmetry. When k is -1, this expression gives 1.413. When k is 1, this phase expression gives -1.413. This exhibits odd symmetry with respect to k equal to 0. That means value at -2 and +2 are equal and opposite. Values at -1 and +1 are equal and opposite. The value at k equal to 0 should be 0 always. This should exhibit odd symmetry. Values at -2 +2 are same. Values at -1 +1 are same. And value at 0 is 0.632. I am going to plot the spectrum. I am going to plot the spectrum now. X-axis is k, y-axis is magnitude of x of k, 0, k1, k2, k-1, k-2. When k is 0, it is 0.632. When k is 1 and -1, it is 0.01. When k is -2 and +2, it is 0.05. 0.05. Please note that this figure comprises of lines. Therefore, the spectrum is also called line spectrum because the spectrum comprises of only lines. And it is discrete, it is not a continuous. That I have told in the beginning class, where I put the block diagram and showed x of k is discrete. That means magnitude of x of k will present only at integer values of k.
there will be no line at k equal to 1.5, 2.5, etc. That's what I mean. This exhibits even symmetry. Next is phase spectrum. X-axis is k, y-axis is theta of k. Now when k is 0, it is 0. When k is 1, it is minus 1.413. When k is minus 1, it is plus 1.413. When k is minus 2, it is 1.491, and when k is plus 2, it is minus 1.491. Some of the representative values only are shown. Actually, you can plot the spectrum right from k equal to minus infinity to plus infinity. This spectrum exhibits, I repeat, even symmetry. This spectrum exhibits odd symmetry. And even here we have got lines. Therefore, this is also called line spectrum. With here we stop.